this is a participation grade. All right. I mentioned that is permutation is kind of a bit of a issue. So I'm going to show you at least the way I've done it. So, and also kind of the strategy behind how to solve problems that have Booleans in them. So first off, I said public static E to say, hey, it's a permutation of, basically we're trying to work on two lists of some unknown type, but the lists are going to be the same type, A and B. So that's another thing why we want to use generics. By doing this, we're enforcing that list A and list B are going to be the exact same type. This enforces that. They have to be the exact same type. So that's very useful. Now, first off, when we're dealing with like things that we are given something and we're trying to produce a Boolean, a true or false, figure out which condition is easier to prove. Is it easier to prove that that they're not a permutation or that they are? With the case of like it's of unique, right, that we did first, it's easier to show that things aren't unique, right? All you have to do is find one contradiction. So that's generally what we like to target. If you can find one contradiction, that's great. So what you do is you assume it to be true or false, and then as soon as you find the thing that contradicts it being true or false, you're able to return the opposite. So for here, what we're going to do is that we're going to assume that A and B are permutations of each other until they aren't. So what does it mean for them to be permutations? It means that A and B have to have the same number of the same characters, and they have to have the same character counts of each character. So let's see. So I'm just trying to think of so for instance, Flo and Wolf, two words that are made up the same letter and have the same characters, right? They each have one F, one L, one O, one W, right? Both of them. So these two words are permutations of each other. Of course, there are words that basically have other ones. I'm just not thinking of, that have multiple characters in them. I'm just not thinking of them right now, though. But in an abstract level, we also care, right? AAB versus BAB, right? Or sorry, ABA, right? Those are permutations of each other. On the other hand, AAB and BAB, they're not permutations of each other because B is, we've got two B's here and one B here, right? The character counts are different, right? So first, this does lead us to a useful insight. They have to have the same number of characters. If they don't have the same number of characters, they can't be permutations of each other. So and I'm breaking, some law by using single variables names, single letter variable names and making them capitalized, but whatever. If list A and list B don't equal the same size, so again, that was my compiler doing an awesome thing where I just simply do the not sign and the equal, and it combines them into two. And my font combines them, not my compiler. And B dot size over here. We get A dot size is not equal to B dot size. If those two things are different, we can immediately return false because we don't even have to check anything. If they're different sizes, they can't possibly have the same character counts. Okay? So the next thing we have to do is that we have to count the number of characters. So what we're going to do is that for every character in A, so I'll use a for loop here just to make it a bit easier. A for each loop over here, so it's going to be a bit easier for me. For let's see, E item in A. So for every item in A. Okay, so I'm going to go through every item in A. It doesn't matter what order I'm going to go into them. I'm going to count the number of times that character appears in A, and I'm going to count that number of times that character appears in B. So this is, right, so for every letter in A, I'm going to count how many times it appears in A, how many times it appears in B. So, So what I'll do is I'll need two variables. Count A, which is going to start out as 0, and int count B is going to start out as 0. Right? So I've got count A and count B. And so for int I is equal to 0, I'm just going to go through the index. I is less than a dot size. I'm going to go through every character and go I plus plus. And I am going to count every single character there. So I'll ask myself, what do I ask myself now? What's the next line I should put? An if statement, right? What's the if statement? Want to check if it's equal to the item, right? So if item equals, or rather dot equals list dot get I, or rather a dot get I, if item is equal to a dot get I, then we increase count A by 1, right? So I go through, so I take the item, and what I do is I go through each of the items and ask myself, hey, is this item equal to the item that I'm looking at in the list? If it is, I've seen, oh, sorry, I'm seeing, see, all your fault because you yawned earlier. I've seen an additional instance, additional instance of that item, so I increase count by of that count by 1. Okay. Next, I have to do the same thing for B, which all I'm going to do is just select this bit and copy it and paste it. So select it, copy it, paste it. So I take this duplicate of the for loop, and all I do is I change those instances of a.size to b.size and a.getI to b.getI, and count A to count B increment. Right? So that's all that takes. I go through every item in A, I look at all the items in A again, look at all the items in B, and update their respective counts. Right? Make sense? And then the next thing I got to do is make sure those counts match. So I ask, if count A is not equal to count B, if those counts don't match, then that means I immediately know it's not a permutation. So I get to immediately return false. Does that make sense to everybody? If those counts don't match, I return false. Now, here's the next question. Do I have to copy and paste this loop again, but do it for every item in B? And the answer is no, because, but it's not necessarily no for the reason you think. It's because we know A and B are the same size, so that means that the counts all have to match for them to be permutations of each other. So if they're both the same size, then we know that we can go through with this for loop. And that if we've checked all the items off for A, then we aren't going to get into a situation. It's impossible to get into a situation that's A, B, B, E, and A, B, C, right? The counts of the A's and B's won't match. So there's no room for this mystery character to appear out of nowhere. So because they don't match, we can check that, and it will work out just fine. So if we get through this loop, we get to return true. So like I mentioned, this is a bit messy, right? If we take a look, line 43 to line 19, and I did leave some spaces in there, but it's still a pain. It's still a painful amount of code, and it's actually just as long if you do it in a more efficient way. Now, as you previously mentioned, though, there is a way to do it that's a bit shorter, but it only works on things that are comparable, right? So part of this is that this is permutation will work on anything, right? Any type. But say that though I can actually add an additional restriction. Public static E. So I'm going to type something that looks weird for a lot of reasons. Is comparable E. Boom. Extends comparable. This is going to be an error because it doesn't know what a comparable is. Comparable. Stack Boolean is perm2 list E A list E B. Now, what is the difference here? Return between this method and the other method. The method here is that I added a condition over here. And the condition is that this is is that basically E extends comparable. This means that any, and you can do this in Java. What this means, or rather with generics, and what this means is that anything that is an E, we're specifying that those E's are also comparables. And we'll get into comparables in a bit more detail later. But what it means to be comparable means that there's order to it. A comparable, anything that's comparable has the compare to function. So here, right, if I create this E over here, E temp, it just over here is equal to new. I don't know if I can do this actually. No, I can't. You can't create those. So, so I'll just say E temp is equal to a dot get 0. So I'll get the first item out. And now, if I do temp notice that it has a compare to method over here. It's got your standard. You've got your standard number of give your standard methods over here, but then we have the compare to method, which comes from comparable. And if you read this, which is small, so you can't read it, but if you do read this documentation for it, it says what it does is that when you compare one object that's comparable to another object, you're going to get an integer back. You're going to get a negative integer if A is less than B, a positive integer if A is greater than B, and 0 if they're equal. This comparable E over here, this nested means that its E is comparable only to other E's. It's not comparable to any other comparables. It's a lot right now to take in, and I'm bringing it actually a couple of chapters early. You're not really going to use this until much later when we're dealing with binary trees, and it's not really as hard as I make it out to be. But I just wanted to show you the short solution for this, the simplest solution, and it only works on some cases, which is that, okay, if I've got flow and I've got wolf, and strings are comparable, by the way, because you can put strings in order, alphabetical order, right? So if you've got flow and wolf, I can actually sort these strings, and I will get them, and I'll put all the letters in alphabetical order. Actually, I get flow, and then wolf would get sorted into flow as well. And then I can just simply say, hey, if they're sorted, if two things get sorted in the same order, then they're going to be permutations of each other, right? Because two things are the same permutation. If you sort them, they are going to be exactly the same. So it's pretty. So what I'll do is simply say list E A. So let's see. Is there a handy dandy sort function that's already included in? Let's see. And there is. There is a sort function that you can find in the collections class. And I'm showing this because a bunch of other students from last semester, they find this and they try doing it, and then they wonder why it won't work. But what you can do is that you can give any list, you can sort any list by passing it to collections.sort, and it will sort that list. A collections dot sort B. And I'm going to show you how we can condense this all down into one line. It's actually pretty funny. Okay. Actually, I don't think I can because, hold on, what does collections.sort return? Does collections.sort return anything? Except, yeah, you can totally look at class code. Oh, right, Control Q. That's how I get it. It does not return anything, which is a shame. So I can't do this in one line. Okay. So ixnay on that. List.sort comparator null. Excellent. Okay. So I could get it down to one line. It would just look horrendous and terrible. Okay. So sort collections A, collection B, sort, and now that they've been sorted, we can just simply say, hey, if A dot equals B, right, because everything has a dot equals method, return true, else return false. Now we can condense this statement pretty simply, actually, by using what one textbook calls Boolean Zen, which means that if you test something, and if that test is true, then return true. But if that test is false, you're going to return false. You can just simplify it. In fact, it's coming up with a warning over here. Control F1. You can simplify it to, hey, you can just return that test. So I can just return instead A dot equals B instead. And so, yeah. Now, the last disadvantage of this method is also if you do sort A and sort B, then A and B are now going to be changed because the sorting method actually sorts them, so it does change them from what they originally were. So that is an issue with that method. All right. So you can go ahead and turn in the code you have for that one. Also, if you're done with that assignment, I'd be happy to check you off. If otherwise, you can keep working on that assignment if you need the time here. If you don't need to keep working on the assignment, then there's an extra credit assignment already up for doing regular expressions. It's part of the reason I have the regular expression assignment is in case you manage to get that part done. All right. I will introduce you to the site regexer, but also you look up regex tutorial anywhere and you'll be able to start working with regular expressions. Regular expressions, by the way, they are super, super useful. They are these fancy find replace functions. Okay? And regexer allows me to kind of test them out. So the first thing I can do with regular expressions is that I can kind of just search for stuff normally, right? So if I search for foo in here, it's not going to find it, but if I search for capital T temple, it will find temple in there. It won't find lowercase t temple because guess what? It's case sensitive. However, I can do something like this, where the brackets denote find one of these two things. Right? Or brackets denote find any character in here. So I could find temple, capital T temple, lowercase t temple. Also, I could find remple. I don't know what that is. I hope it's not a previously heretofore known curse word. So remple. So that will match temple, temple, and remple. Right? So that's one way you can do that. Now, the other big powerful thing about this is that we have what are called meta characters. Okay, and meta characters are these characters that are special characters that have special meaning in regular expressions. So, for instance, period is the wildcard character. It will match anything. So it will match temple, remple, also femple, and bang emple. Right? Right? It will match anything. It will even match space emple. Right? Any character. Okay, what about because I don't have Japanese on my keyboard installed at the moment, an oversight I will have to fix. It'll match even the Unicode. Ka emple. Because that is the Japanese character for ka. Right? So it will match anything. If we did, so another thing we can, there's a couple of other meta characters that we saw, the open curly and closed curly brace. There's also characters such as so I'm sure that if during when you've IM'd, you've done LOL before, and if you thought it was really funny, you might have gone LOL, right? No, some people have. Yeah. All right. So what we can do is, if we want to match any series of LOL, no matter what, is that we can put like the thing we want to match additional of in a parentheses like this, LOL, and say that's a group of characters. And what I can say is that I want to match at least one of those LOLs. I'll use another meta character, the plus, the quantifier, and that says it'll match L followed by one OL. It'll also match it followed by two OLs, or followed by three OLs, or followed by four OLs. So it'll match LOL, OL, OL, OL. Right? So it'll match at least one of those things, which is pretty useful. Right? Or going back to our temple example, T, let's see, T, capital T, followed by that, plus temple over there. It will match temple, also match semple, or any number of those, right? Any number of T's, right? Any number of those T's followed by an E and MPLE, right? There's a very similar operation, also known as, so there's the plus sign, but then there's also a very similar operation called the clean star, which means I'll match 0. So the plus was at least one of, the clean star is 0 to an infinite number. So this will match temple, but it'll also match the emples in all the other examples we have here. And there are a lot of different, so there's a whole lot of different tools you can use for regular expressions. There's a cheat sheet here. There's all sorts of symbols that we can use. So for instance, you've got, we can make our own character classes. One you'll be using a lot is AEIOU, which matches any vowel, right? You'll be using that a lot in my examples. Another thing but if you want to match any letter, we can use /W, which matches any character. So that matches any alphanumerical character, which is a W, which is any letter, capital, lowercase, a number, also the underscore. Basically anything you might make a variable name with. So if we do plus, right, anything, we notice that now anything that could be a variable name gets highlighted, essentially. If we use /D for digits, okay, and then we use /S for white space. And if you capitalize any of those, /W, you get the inverses. So anything that's not a letter, anything that's not white space, anything that's not a digit. Okay, I'm almost done with the cool tricks from this. There's a couple more to learn. I'd take a look at them. Now, why am I bothering with these? they're available in almost every single language, and they make your life a heck of a lot easier. If we look at the string theory, beans, school, lights, there we go. It's interesting that I think string beans was super important to me. Okay, if we look and search for regex in here, which is short for regular expression, we notice that it occurs 25 times in the string package. So it occurs for, you used it for the split function. You can use it in the in matches, in replace all. So knowing how to use regular expressions is pretty nice. Also, they're pretty much usable in any programming language, not just Java. So one more thing we can do, I'm going to go back, if we can go back, and I already showed you this example on Tuesday, but I'm going to go over it again here. If we go back to the, to brush up against politics for a second, if we go back to the 2016 campaign, if you remember, Jeb Bush was a front runner for a while in that campaign, okay? And he was well known as the e-governor because he was very accessible via email, and long story short, in an effort to show how transparent he was, he released all the emails he had received as governor and answered. However, this was not necessarily vetted that well. Jeb Bush, Bush email, and verge over here. Jeb Bush dumps emails including social security numbers of Florida residents online. Right, because people would send them his social security their social security numbers in their email, because of course that's a safe person to send it to. He is the governor and will not release that. Ideally. Also medical information like, hey, I'm just trying to get help with basically this, surgery I'm trying to get for a child. So it was very important stuff. And the social security numbers just used that way because we don't have a good identity system in the United States because we're closer to 50 really closely knitted together countries in some ways, and in some ways we're one country.
Just got our identity stolen.
It's pretty brutal. It sucks, and we don't have very good identity cards because Social Security was never meant to be used as identity. But the way Social Security got really well adopted was that in order to collect Social Security benefit for your children, for saying you had 7 children, you need Social Security numbers for all of them to claim the child tax benefit of having 7 dependents. So that helped adopt that. There are some edge cases where actually there are people who don't have Social Security numbers, but it's very small edge cases for the United States, for even U.S. citizens not to have it. Some specific religious communities. CPG Gray has an excellent video on it. Anyway, so one of the powerful things about regular expressions, though, is that we can easily look for something that's like a Social Security number really quickly by saying, okay, a Social Security number is the form of 3 digits, so /D/D/D/D, any 3 digits, followed by a dash, followed by any 2 digits, followed by a dash, followed by any 4 digits, right? So I can just simply go, so if this is your Social Security number, 12345-6789, and I'm sorry if that's your friend's Social Security number, but or any of yours. I didn't mean to totally out you. But that's something that can be done with this regular expressions that can't really be done with the find replace function. But the find replace function does, most Microsoft programs like Office and the like do support this kind of functionality. Do support regular expressions. Regular expressions are extremely powerful. In fact, even in our IDE, if we press Control F, notice over here I can select the checkbox regex, and it will start looking for stuff using regular expressions. I can actually simplify this a bit more by doing this. This means exactly 4 Ds. for exactly 4 digits, right? So if I have braces like this, I mean that. Another way we can do that, another use of that is that I can use comma to mean at least 4 of, and I can also then do, say, 4 to 7, and this would mean it would match anywhere between 4 and 7 of these things. So that's so my my extra credit goes over uses a file, a dictionary file. Now, the dictionary file does have all the words in the English language, including the ones that we really don't like, or at least the ones that they'd like to pretend that nobody uses, right? So, but it's also the one that I find, anyway, but let's see, I had a complaint from a student about that. So just fair warning that basically that user share dictionary. This is what, so you basically have a dictionary file on your computer probably of some kind that basically is just a list of words. So, and what it does is that it just simply says, hey, is it in this list of words? Is the word you're trying to spell in this list of word? And if it is, it's a valid word. That's how spell check works. It's just a list of words. And as a dictionary file. So I think I use this as a dictionary file for our assignment. And basically ask, okay, how many words end in ION versus how many words end in IOG? Okay, so the question is, how do we read a file like that? Because how many of you have done file reading in Java? One of you. Did you use buffer reader or anything like that? No, good. Okay, file reading in Java is obscenely easy. How many of you know how to use scanner? Congratulations, you know how to read files. Because that's how we're going to totally do it. So I'm going to just, for the sake of example, download a text file, not the one you have. I'm going to go to projectgutenberg.org. Gutenberg.org. Okay. Browse catalog. You know what? I'm just going to go ahead and grab a good old Bill. So William. Complete works of William Shakespeare. Actually, we're Philadelphia. We should grab the autobiography of Benjamin Franklin. Why not? Okay, so I'm going to grab that as a text file. I'm going to go ahead and download it, save it to desktop for a second. It's PG148, right? Close this terminal, minimize the recording thing. And all I'm going to do is that I'm just going to copy this and I'm going to put it in the top. So to read a file, you need it to be in the project folder that you're adding. Don't put it in the SRC folder. Put it in like here. So I'm going to post it right over here. Or sorry, I'm going to put it right over here in this project. So Control C, Control V. I thought it would work like that. Why isn't it working like that? Come on. Is it because I have to do it like this? I have to go into files and have to go into desktop and then I have to copy it and then I have to clone it over here? Yes, because thank you, GNOME. You are sometimes very weird. Okay, so I've got this file here. So how would I read it, right? And reading a file is very, very easy in Java. You have to use a try-catch loop, and if you haven't done that, that's okay. Public static void public static. You know what? I'm just gonna put in main psvm main. And this will be an example on how you read this file. Okay. So how do we read this file? First thing we need to do is create a scanner. We create a file object. File f is equal to a new file. So this is a file object. You just need to import it from java.io.file. And the constructor takes the location of the file, which if it's in the same location as your project, then it's just the file name. Right? If you put it over here, so that's not in the SRC, that's in the wrappers or in your project name, then you just go pg148.txt. Right? So you just put the file name over there. And the next thing we do is we create a scanner. Scanner, Okay, import scanner is equal to new scanner. And by the way, how do I import stuff so fast? I'm pressing Alt-Enter, and that will just import that. Okay, and rather than giving it system.in, I give it F, the file. Now this will give me a warning, and if we read the warning, it says unhandled exception, file not found exception. In other words, I need to make sure that if the file doesn't exist, it's handled in some way. There's two ways to deal with that. The first is say LOL nope, and put a throws exception up here, which just simply says, hey, I'm not going to worry about handling exception. Any exceptions that arise here, that's just going to I'm going to let that crash the program. The correct way to do that, though, is to do a try-catch block, which is that you put any code that might break this in a try block. So we'll do that. Try, which means we're going to try this, and if an exception gets thrown, remember that language? We throw an exception. Instead, we'll just try to catch it. Exception E, and I'll just simply say, and here I'll say sir as opposed to sout. System.err.println, and that's how you get and the error. So there's three streams. There's input, output, and error. Error will just simply produce errors, and we'll say file not found. Okay. Which, if we run this as on 149, which is not the file, you'll notice that I'll get a crash. File not found. And it comes out all official looking in bright red or dark red. If I instead do 148, it's not going to get any output because I told it not to do anything. Okay, so we've got a file. So how do we read it? Well, what we're going to do is that we use a loop, which is a very simple loop. While the scanner dot has next line. Well, there's still another line of text to read from the file. While we can still read text from the file, string line is equal to scanner dot next line. Every time you read next, you call next line, it advances to the next line. So be sure to not call it too many times. But that's all you have to do to read a file. While you create a scanner. While the scanner says there's still lines to read a line. There you go, you have that line of the file. That's it. That's all there is to it. That's for reading files in Java, at least, is very, very easy, easier than what I had to do because I'd have to create these files which would be passed into Buffered readers, which would be passed into file readers, which is stupid. Use scanner until somebody tells you not to use it. It's perfectly fine for class.
Does next line mean like next word?
No. Line literally means line. So
it'll split all of that line
into a string.
Okay.
But you can also use some of the knowledge about the file you're reading. So with the dictionary file I provide you, you're only getting one word per line. So you don't have to do any split operations or anything like that.
Okay. Does it read it as if... I thought like it'll pretend like everything's on one line and it'll be separated by like /n.
It does that, but it's reading up until what next line does is that it grabs up until it sees a /n.
So would you be able to just read like next word, next word, next word?
You can with next, but I find I get a lot better control. I find it's easier for me to do the thinking if I just think of it in one line, another line, because I can see a line very easily. Lines are predictable to me, whereas I find individual words not to be predictable. You sometimes get weird tokens and stuff. Anyway, so that's all I have to say about the subject. So I'll come around and help. If you haven't demoed and you need to demo the assignment from today, please do so. All right, let me go ahead and whoop, and there. That's what I wanted to get.